All right, it's time to solve number 7, the last question on the assignment. We couldn't get over in class, so I'm going to walk you through how I would do it. And so just follow along. So we have someone pulling themselves down with a rope and lifting themselves up on the other side of a pulley. And we just want to know how hard she must pull to give herself, to let her raise at a constant speed. So if you're going to do part A, you know that the constant speed statement is telling you the acceleration is 0 for the system. And so this means the net force is 0. So the upward force on her, we'll call it tension. And the downward force on her is her weight. And all of this equals 0. So this means that the tension must equal her weight. And because she is pulling down here, this is actually what's providing the tension in the rope. So she is going to simply pull with her mass of 65 with the bucket times 9.8. And that gives you a downward pull of 637 newtons. We did it. Now, part B. Part B, she's going to pull with more than 637 newtons. She's going to actually increase this by 15%. So let's figure out what is she pulling by multiplying by 1.15. That's 115% of the actual pull. And it comes out to be 732.55 newtons. This is now the actual force that she's lifting with. So therefore, this is also now the tension force. So if I wrote a net force statement, the tension force minus the gravitational force is going to equal MA. And of course, the A is the unknown in this case. That's what we're going to solve for. So now we plug in the numbers. So 732.55 minus her weight, which we previously calculated to be 637, equals the mass times the unknown. And if you rearrange the numbers and do the math, you're going to find the acceleration to be 1.47 meters per second squared. Yep, that's what she lifts herself up, the acceleration she'll ascend with. It's been a lot of fun doing these problems with you guys. For following along in these videos, I tell you what, if you can draw a Miami Dolphins football helmet on your quiz, I'll give you some extra credit for taking the time to watch how I solve these. Thank you.